Well, they sure don't make them like this anymore, I'll tell you that. This is a lovely old Rockford Fosgate 2K. Yeah, it's quite an early Class D, and for its time, it's pretty sophisticated. Pretty complex board design, lots of SMD components, lots of fancy bits and bobs on here, ICs, etc. And this one came in with a broken inductor. This, the original glue that held this in place, you can see here, absolutely no good whatsoever over many years. Come completely solid and hard. Wasn't holding this in place at all. So this was vibrating around and it snapped a lead down here. And that prevented there being any output. The amplifier turned on and seemed to be okay, but there was absolutely no output. So rather than doing an expensive rewind on this, I literally just wound back one turn on the inductor, and then I checked the inductance was still high enough to filter out the radio frequency switching stuff for the Class D, which it was, and then all I had to do then was loop it round and put it back in the original hole, and it's up and working perfectly fine. That is a considerable saving for the customer, allowing me to do that. I always let them know. I say I'm going to remove one of the winds on the inductor that has this effect, and I show them what the scope looks like before and after with the inductance, with the high frequency switching wave going through it, and what the resulting audio wave looks like afterwards, and they look damn identical. You can't tell the difference. So you losing one winding here isn't going to make any difference whatsoever to how this amplifier sounds, and it's a big saving for the customer rather than having me rewind this whole bloody thing because it's now too short. As you can see, I put some very hefty amount of mastic around there, and this is not going anywhere. You could pick that up and lift the amp up with this now, absolutely solid, and that should last for many years to come. Other than that, nothing wrong with the amplifier. A bit dusty, we'll clean that up, works perfectly fine. Okay, let's bench this old Rockford. Will the old girl make rated power? I have quite a lot of faith in these old school amps, and I reckon we'll see at least rated power here. So this is too big to fit on my bench with the power leads where they are, so we're going to just focus in on the scope here so you can see what's going on. Okay, let's get my multimeter on the power round as well. Cool, let's fire up and see what we do. Okay, getting down to minimum to start with. Let's turn that back to 5 US and bump it up to 20 volts. Okay, so already got quite a nice wave there. It's not too bad. Okay, let's crank it up. Okay, that's our clip point. There we go, that's our clip point. And you can see at that point the power supply struggles. All the way down to 9 volt there. I reckon we're down to like 10.2 there. Okay, so I'm going to go ahead and use 10 point something, 10.5, 10.2. To kind of gauge what that was doing there. We've got 36 volts on the oscilloscope there, but what I would say is that when that 36 volts was on the screen, the multimeter wasn't dropping quite as far down as 10 volts like when it did a moment ago. So what I'm going to do is I'm going to use 11 volts, okay, as a reference. This is going to be a rough bench test because obviously this is drawing too much power from my power supplies to be able to bench properly. So let's zoom back out here. Let's look at the old mobile phone. I've got 2% battery, so will I be able to do it? So that was 36.02, and that was at 1 ohm. I think we're going to be quite surprised here, guys. So that was 12.97 already on the, and that was down, way down at like 11 freaking volts. So let's go ahead and work that out. What would that be? So we've got 14.4 divided by 11 volts with a correction factor of 30909. Correction factor of 1.7 times that by 1297.44. 2223 watts. So that is very good from this old school amplifier. Fantastic stuff. There we go. Now this one's great. Now this is a JBL GTO 14001. Absolutely phenomenal amplifiers. I love these things. They are very powerful, really well designed, really well built and put together, have a lovely sound, and they are just solid amplifiers. You can get them quite cheaply now as well, and they were never that expensive to start with. Fantastic pieces of kit. This one's got a funny issue with the output. Now let's just have a listen to this first. I've got this hooked up to a speaker. So we've got some strange noise going on, and the noise changes depending on how well the connection is. And it also changes with input voltage. 9 volts, 12 volts, 13 volts, 14 volts. Back down again. Back down to 9 volts. Also changes when you push in the speaker. So we need to see what the hell is going on here. So let's have a quick look over at the output section. So we've got the nice big switching wave you can see there on the screen from the one side. Now on the other side, which is the low side, we have, let's just check this. So yeah, we've got nice big high side, nice big low side. Yeah, that looks good. So let's, what's on the other side then? Oh dear! What's that? So you can see it's trying to build a wave and it just tapers off. So there's something not right with the driver. See that there? And you can see how that also changes as we mess around with it. And also when we increase the voltage from 9 to 12. If we remove the speaker, interestingly, let's make this a bit smaller so you can see what's going on. You can see all the waves going crazy there. Come back down to 9 volts. If we remove the speaker, we get like a double only, which is weird. It's like a double kind of wave there. And if we make this even smaller, you can see there, it's really trying hard to build that wave. Okay, so enough of that. We need to find out what's going on. So we found that it's this side which has the issue, so we need to work out which driver board that side is connected to. Let's just wait for the rail voltage to fall down on this. Where are we at? 20 volts. Let's just wait for that to sink all the way down to 0. Okay, so now let's check this out. What's going on here? So the gate for this side is over here. So let's work out which driver board then feeds this side of outputs, which all had the one with the issue. And we may need to flip the board over for this, so I can actually get to all of those pins, because this is a double stacked pin on the driver board. They've got 2 sets right next to each other, so you can't get to them from the top. So it was the inner side, wasn't it, that was the bad ones. Okay, there we go. So this is the innermost driver board, which is this one. So we need to go now ahead and remove that. Okay, there we go. I kind of cheated on this one because I actually had a spare driver board laying around that was fully functional. So I didn't really need to diagnose too much on the driver board on this one to get this up and working for the customer. I've got a massive backlog of amplifiers because I went away on a holiday for 10 days, so I've got a lot to work through. So if I had more time, maybe I'll probably sit down and go through this driver board, work out exactly what the issue was with it. But I haven't really got the time just now, and I'd rather get this back to the customer in good time. So this is the driver board from this amplifier that had the issue. So at some point I'll probably go through it and work out what was wrong. I imagine it's probably the 2010S driver chip. So replace that and it'll probably be all good to go. But rather than doing that, I thought I had a spare driver board laying around, so bang that in and she's all good to go. So we've seen a Taramps before on this channel, but that had a power supply failure, and this one has an output section failure. It's slightly less common to see on the Taramps, to be honest. Most of the time it's the 1404s on a power supply that go down. But at this one we've got one bank here of output FETs which are down. Now, in these amplifiers, the outputs are worked in pairs, in banks of 2, and each pair is driven by a single driver IC which has a high side and a low side. Unlike big Korean 10Ks, this is a 10K amplifier, believe it or not, if the output section dies in a Korean amplifier, generally you really want to go about replacing all of the FETs in the banks which are dead. So if you have all the FETs along one side that are dead, that's going to be like 16, 32 FETs to replace, and it gets very expensive very quickly. However, in these Taramps, in these full bridge Class D Brazilians, we've just got one bank here which is dead. The other 3 banks have survived. Now, you probably could get away with just replacing these 2 FETs and things might be fine. If you're slightly less unlucky, you might have to replace these 2 FETs and this driver chip here, this driver IC, which may have been damaged in the process of these blowing. But what we're going to do today is just to iron out any future possibilities of difficulties where any of the parts here may have been damaged when these blew. We're going to replace these two, even though they're fine, and the driver IC, so that this side of outputs is completely fresh and of the same batch. We will also check these Zener diodes here, which sometimes fail when the outputs die. Because of how these boards have been assembled, we can actually get away with pretty much doing a top board repair. I don't think I'll need to take this amplifier out of its casing in order to do this repair. The MOSFETs here, we can heat up the pads from the top one by one, suck the solder through, and the MOSFET will just pull out very easily. Then we can suck the remaining solder away from the holes on the other side of the board, fit the new FETs in place, and solder from the top, holding it on long enough for the solder to seep down onto both top and bottom pads, and that makes for a perfect repair on both sides. And obviously the driver IC we can heat from the top, and that's fine as well. Now, as we can see, the driver ICs have been masked off by Taramps. Now these will be mostly one of 2 models of FET, whether it's a 14 or a 16 leg. This looks like it is a 16 leg, and this is probably going to be a 2092 by International Rectifier. The other possibility is it could be a 21844S, but those are more likely to be used in a Korean style amplifier. All of the Brazilians that I've seen have used these, which are the 2092s. So what I'll do is I'll just check the schematic anyway to confirm, but I believe that will be correct, and that's what we replace with. Okay, so I know I said I was going to do a top board repair on this. However, I just remember that the customer who brought this round also brought a Stetson 5K with very heavy vibration damage. He had it mounted to the side wall of his van, which was flexing like crazy from the bass, and the Stetson 5K had a load of MOSFETs which had snapped leads from the vibration damage, which causes the board to warp from the middle and put stress on the legs at the side, and we only had 3 out of 12 power supply MOSFETs still connected to the board, which is why they blew. So I just wanted to check this amp over for vibration damage because it was mounted in the same place. So the only way to do that is to remove all the FETs, take the board out and give them all a wiggle, make sure that none of them are disconnected from the board. And it's a good job that I did, because check this shit out right here. Remove the board. What the fuck is that? As you can see, whatever the fuck has gone on with this inductor is the reason for this bank of MOSFETs blowing. So I would say that we either have a case of a snapped inductor lead slightly above this, and what that would cause is if the inductor lead snaps, then it's obviously still kind of touching the bit that is snapped off, and it creates a high resistance and a spark. It arcs across the break, and what happens when you have arcing and resistance? You get heat, and serious amounts of heat when 10,000 watts is concerned. So what we've probably got here is this has snapped off of the board just in here, and that's what's caused that to heat up like crazy. All that blackness is from the arcing and the sparks and the heat, and the solder here, which you can't, I don't know if you can see on the camera, the solder there has just kind of gone away from the lead there, where it's obviously got so hot it's melted the solder and repositioned it. So we have got some work to do on this inductor then as well. Yep, so as you can clearly see, we've just lifted the inductor off the board there, and the break is very clear. So this obviously has snapped due to vibration, but it's still touching that pad, and so some of the electricity is still passing because it's quite a high voltage that comes out of this. It will be jumping the gap, and it'll be sparking against this pad, creating immense amounts of heat, and that's what will have killed this amplifier. Keep your amplifiers off of your boxes and vibrating surfaces, guys, if you want your amps to last a significant amount of time. Okay, there we go. So we resoldered on the bottom there. Nice clean pad. We've cleaned that up a little bit as well. And on the top of the board here, what we've had to do is extend from the board up to where the lead is. Now, the customer didn't want me to go ahead and rewind the whole inductor because that would have been very pricey. So to keep it down for customer, the limited budget, what we're going to do is just extend it up from the bottom, soldered top and bottom, very, very secure connection on the board, more so probably than the original lead on the other one. And then this top bit of wire here, we have intertwined what was left of the copper wire. We've sanded off the remaining insulation from the wire, intertwined that with these strands, and let solder soak in for a decent amount of time to the strands and around the bit of wire that's intertwined with the strands. It's a very, very solid connection. It doesn't look too pretty, but that is much lower resistance than anything else on the board, and it is very, very solid. What we're going to do is apply new mastic all around this to stop it from vibrating, and also on this new connection. And I'll probably go ahead and apply some mastic to this other one over here as well, just to prevent that from, you know, getting any issues in the future where it's obviously been shaken up a bit anyway. So that's all attached. Let's just check the inductance to make sure that it is as it should be. So we've got the original inductor over here. Let's measure that and just get a reference for what the inductance should be of this one. 17 UH and very low resistance there. So let's go ahead and measure the one we've just repaired. $17 UH, so it is exactly the same. There we go, perfect. Okay, 4 new outputs are fitted, and now we just need to change the driver IC here. It's a good job I checked the schematic, as this amplifier actually uses an SI8244 from Silicon Labs, not the normal kind of IRS chips. So what we'll have to do is jump on Mouser and order a couple of those, as I don't have any of those in stock. And they should get here by the end of the week, and we can go ahead and fit that just to be sure. I probably could power this up now with the original IC in there, but it's a bit of a Schrodinger's cat scenario. Is it dead? Is it alive? You don't know until you fire it up, and then if you fire it up with this much rail voltage on the outputs, if there is an issue with the IC, it's likely just to kill the MOSFETs that I've just freshly fitted in there, which I don't want to do. So for the sake of a couple of quid, let's just replace the IC. So this is an Amtech's worst nightmare. This is JBL Audio 500/1, and these can be a bit of a headache to fix because they are so heavily IC controlled and all sorts of other bits and pieces going on. Very complicated amplifier, and the reason for that is because it does the power at varying impedances, one of the reasons, and other reasons, protection circuitry, drive circuitry, etc. we won't go into just now. Very fucking good amplifiers though. JBL Audio, gotta hand it to them. Their amplifier design is off the hook. Very, very nice stuff. So this one came in with a dead power supply. As you can see here, we have replaced those with the 3205s. It looks a bit of a mess on the board there, where obviously things got a bit heated up, but not too much of an issue. All of the gate resistors are well within tolerance. They read perfect, and they just got covered in soot from the old transistors. We've cleaned that up the best we can, but a little bit scorching to the board. So power supply is all up and running good. Output section, now I forgot to film this because this was ages ago I started work on this, and I just got back around to it. Now for the output section, to force it to oscillate without any outputs in, we have to put a jumper across the drain and source of these middle ones here. and this one, which I've just removed because I'm just on the way to finishing this off. So you jump the drain and source of the two middle, high side I think they are, and you also have to, which I've also just removed, jump these two pins of this IC. You can kind of see where I've had the soldering on there with a little bit of flux. So yeah, pins, I think it's, is that 1 and 2? Yeah, pins 1 and 2 of this IC, you jump, and then you jump also drain and source of these outputs, and that forces the amplifier to oscillate without any outputs in, and you can check the square waves, etc. on the scope, and we're all looking good. So what we're going to go ahead and do now is fit the outputs, and I'm going to upgrade this ever so slightly. This uses 540s. I'm going to put the 540Z, which run much cooler. Just makes the amplifier a little bit happier, a little bit more efficient, and we've also had to replace a lot of these drivers over here, 1, 2, 3, 1, 2, 3, and these 470 ohm resistors here and here. Apart from that, the output section should be good to go, so we're just going to fit those and fire it up. Okay, so the JL Audio 500/1 is all up and running. Now once again, fucking very clever JL. So this amplifier, I've got my power supply here, which I can range between 9 volts and 15 volts for amplifier operation. Fucking phone. Now check this out. This is the rail voltage which we see on each of the speaker terminals. If you probe the speaker terminal, reference to amplifier ground input, you see half the rail voltage on each speaker terminal. Plus, and on the minus and minus. Now it's always at 40 volts on both of these, which means that the speaker sees 0 volts. And what this lets the amplifier do is it lets the amplifier swing the audio from what the woofer thinks is 0, what we see as 40, up to 80 and down to 0. So the subwoofer sees 40 up, 40 down, and we see 0, 40, 80. So what I wanted to show you was the power supply. So this is the rail voltage here. We've got 39.49 volts there on the half rail. So if we now switch the power supply down to 12 volts, usually on all other amplifiers the rail voltage then drops, but not on the JL. Again, drop it down to 9 volts. So this is with hefty voltage drop. Rail voltage is still exactly the same. So this amplifier will continue to do the same power regardless of the input voltage from 9 volts all the way. Watch the oscope screen. We're not going to change from 9 to 12, 13, even 15 volts. The rail voltage is still the same. All that happens is that at these lower voltages like 9 volts, the amplifier will just demand more current from the built-in power supply circuit. Fantastic design feature.